somehow we are already at the end of Unit 2, and we are reviewing for the test that's coming up soon. So, starting with number 1 and 2, we are just identifying each transformation. So going from the blue to the red shape, that would be a translation. And then for number 2, going from the blue shape to the red shape again, this one would be a rotation because that shape is just twisting around. So then for number 3, we have a figure with vertices x, y, z. After transformation, the image of the figure has vertices x prime, y prime, and z prime. Graph the pre-image and image and identify. So we will start with x, y, and z. So x is at 3, -3. Y is at 1, -2. And z is at 3, 0. So then looking at the translated image or transformed image, x prime is at -3, -3. Y prime is at -1, -2. And z prime is at -3, 0. So now that both of these are graphed, you can more easily tell that this is just a reflection across the y-axis. And if you recall, that rule for your ordered pairs is -xy, so that makes sense for all of these. So then that is going to be a reflection. So then we want to graph the image and pre-image after reflection over the x-axis. So if you recall, the rule over the x-axis is x and an opposite y, -y. So if s is at 6, 2, s prime would be at 6, -2. T prime would be at 6, -6. U prime would be at -2, 2, because again, we're just keeping the x value, changing the y value. And then b prime would be at 3, +4. So then we're going to graph these both on the same graph and label. So we have one at 6, 2. T is at 6, 6. U is at -2, -2. And V is at 3, -4. So it looks like we have a quadrilateral, and it doesn't look like it's a trapezoid. Boop. But then with the reflection over the x-axis, S prime would be at 6, -2. T prime is at 6, -6. And U prime is at -2, 2. And V prime is at 3, +4. So you can see it just turns that shape upside down. Boop, just like that. All right. So then for number 5, we are going to reflect over the y equals x line. So with this one, that rule is to switch the y and the x values, but don't change any of them. So with r, that's at -2, 2, s is at 5, 0, and t is at 3, -1. So when we reflect over that y equals x line, my y value becomes my x value. So this one becomes 2, -2. And then S prime is at 0, 5, and T prime is at -1, 3. So then when we plot these on a graph, we should see a reflection across that y equals x line. So S is at 5, 0, T. So we have a little triangle. And then with that reflection, R prime is at 2, -2. S prime is at 0, 5, so now it's a y-intercept. And T prime is at -1, 3. So then, we draw some lines. And we make our triangle. And in case you forgot that y equals x line just goes through the origin and just goes up 1 over 1 the entire time. So you can see that these just reflect over that pink line. For number 6, we are rotating about the origin 180 degrees. So that rule, if you remember on that little salmon colored sheet that you were given, that it is a negative x, negative y. So all you're doing is changing the signs of all of your values. So if p is at 4, negative 3, p prime is going to be negative 4 and positive 3. Q is at 2, negative 3, so q prime is at negative 2, positive 3. R prime would be at negative 1, positive 2, and S prime would be at negative 3, 0. So then we already have the pre-image plotted, so that saves us some time. But then P prime going left 4 and up 3. Q prime going left 2, up 3. Then R prime is left 1, up 2. Oopsie. And S prime is at negative 3, 0. So when we connect all of these points, you can see that this shape has just been brought all the way around. And you can kind of compare the size just by looking like R to Q is just 1 by 1, which is 1 by 1 on the other one. So you can kind of check to make sure all of your dimensions stayed the same throughout. So for number 7, we are going to graph and label, and we are rotating 90 degrees clockwise, and that clockwise apparently jumped up for some reason. But going 90 degrees clockwise, that's the same as 270 degrees counterclockwise. So if you forgot that rule, that would be y negative x. So this is probably one of the more manipulation that is required, is switching their position and changing one of the signs. So if a is at 4, 4, a prime, switching the values doesn't matter because they're the same, but it is going to be a negative 4. So 4, negative 4. Then b prime, since it's at 2, 1, the y value 1 comes to the front, and the x value 2 comes to the back, and it changes its sign to a negative 2. So you get 1, negative 2. And then with c prime, we again bring the y value to be the x value, and 0, it doesn't matter if it's 0 or negative 0 because it's still a 0. So then when you plot this, 4, negative 4, b prime is at 1, negative 2, and c prime is at 3, 0. And you notice that this shape has rotated to the right, so that is clockwise. So it's always quick and easy if you just want to visualize how that translation is or transformation is happening. So for number 8, Keegan needs to ride his bike from his dorm room to his next class. Keegan's dorm room is at 5, 7. So 5, 7. So that's the dorm. And his class is at negative 3, negative 4. So we need to find the translation rule that maps Keegan's bike ride from his dorm to his class. So because a translation rule can either look like an ordered pair or something like x plus or minus something and then y plus or minus something, you just have to decide how far left or right do you go and then how far up or down do you go. So for the x value, we would need to come to the left 1, 2, 3, 4, 5, 6, 7, 8, and 9. Oops, nope, 9's too far. I lied. It's 8. But you need to come to the left 8, so that would either be negative 8 or x minus 8, depending on which form you wanted to use. Again, either of these forms is totally fine. So then to get down to the class, we need to come down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So since we're going down, again, that's a negative direction, so it's going to be negative 11 or y minus 11. So again, use either of these forms. You get to choose which one you prefer. All right. So then for 9 and 10, we need to translate using the given rules. So starting with number 9, we want to translate x, y minus 5. So down here we have x, y minus 5. Now this space down here is just for you to show work if you want to. It is totally optional, but you would put something like that. So to find a prime, we would have a -1 because that one doesn't change, but then your y value -5. So 3 minus 5 is -2. So then b at 1, 1 would still have a 1, but then you'd have 1 minus 5. So then my b prime is at 1, -4. And then for c, I would have 4, and then 4 minus 5. So then that gives me 4, -1 for c prime. So then plotting these on the graph, -1, 3 for A, 1, 1 for B, and 4, 4 for C. Oops. When you connect all of these dots, you get a nice little triangle. And then when you plot your new points, -1, -2, 1, -4, and 4, -1. Oops, 4, -1. Would help if I could count. Oops. But we connect these lines, and you can see that this shape has gone down 5, which if you didn't guess from the translate rule, that -5 means you're just coming down 5. So 1, 2, 3, 4, 5, and all of them shifted that far. So then for 10, we are going to translate x plus 1, y minus 6. So thinking about how that looks, the plus 1 tells us that we're going to go right 1, and the -6 or -6 tells us that we're going down 6. So that should hopefully be what it looks like when we are done. But to fill in the table, personally, I don't really like to use the table, but I will say something that has helped me is to just go through and do all of the x values and then do all of the y values. So since it's x plus 1, I'm just going to take all of my x values and add 1. -1 for p means that p prime is at 0 because -1 plus 1 is 0. If q has an x value of 0, q prime is 0 plus 1, which is 1. If r is at 1 for my x value, r prime is going to be at 2. And if s is at 0, then s prime is going to be at 1. I find that when I do it this way, it allows me to just kind of add 1 quicker than I might normally do it. I know I did it really slow that time around, but all right, so then y minus 6. 2 minus 6 gives me -4. 3 minus 6 gives me -3. 1 minus 6 gives me -5. And again, 1 minus 6 gives me -5. So then when I plot these, p at -1, 2, q is at 0, 3, r is at 1, 1, and s is at 0, 1. So it's just a little tiny quadrilateral. Boop, boop. All right. So then when we are graphing this translation, p is now at 0, -4, so it's way down here. P prime, I'm sorry. Q is at 1, -3, or Q prime. See, I did it again. R is at 2 and -5, so that's down here. R prime, and S prime is at 1, -5, so that's right next to it. But then you notice, did my shape go right 1 and down 6? Well, to go from P to P prime, I went right 1 and 1, 2, 3, 4, 5, 6 down. So yes, my prediction was correct. Woo woo, go us. So then for number 11, we're actually going to do a couple of transformations. We are first going to rotate the triangle 180 degrees. So that's going to make it a -x, -y. And then we are going to translate it using the rule x, y plus 4. So x, y plus 4. So to start, we are just changing all of these values. So we have -x, -y. So L would be -3, -4. M prime would be at -4, -2. And N prime would be at -1, -2. So then this is your optional part again, remember. But If I want L double prime, I'm going to look at my L prime and M prime and all of those and go off of those numbers. So I'm going to keep all of the X values the same. So I'm going to fill those in, -3, -4, -1. And then all the Y values, I'm going to add 4. So -4 plus 4 gives me 0. -2 plus 4 gives me +2. And -2 plus 4 is going to still give me +2. So then I just have to plot all 3 of these triangles on the same graph. So we have 3, 4 is L. Then M is at 4, 2. And N is at 1, 2. And we connect our dots. So then rotating 180 degrees, we should expect it to see it on the opposite side of the graph. So -3, -4 is L prime. M prime is at -4, -2. And N prime is at -1, -2. So it did indeed turn all the way around, which is perfect because that's what we wanted. So then the last one, L double prime, M double prime, and all that fun stuff, L double prime is going to be at -3, 0. M double prime is at -4, 2. Double prime. And N is going to be at -1, +2. And then we connect. So notice it flipped around 180 degrees like we thought in the blue. And then for my translation, I just went up 4, which is what the translation rule told me. So we are perfect. Yay! So now we are going to reflect quadrilateral fill over the line B. So remember when we are doing this, you want to draw the line so that it makes a 90-degree angle with your line of reflection. And then you're going to extend about the same length on the other side and put your point. So this one would be L prime. So then if I wanted to do P, I would have to bring this line all the way down here, and then I have to extend a line that's the same length all the way on this side. Now, I don't have a ruler or anything, so I am purely estimating. Ideally, you are going to use a straight edge or something to actually measure these out. But once you get your points, you connect them. So P prime to L prime. So then I'm going to do the same thing. We're going to have I to I prime. That's about right. And remember when you're doing this, a little bit of fudging is acceptable, but it should still look about the same as what the original is. So we are drawing straight down as best as we can, and my lines are not as straight as they normally are, but I have the surface sitting still on a desk right now. But you draw the lines about the same length, you erase the lines, and then you connect the ones to make your reflection. Oops. Like so. And notice it is that L and I are closer to the line. So then for number 13, we are going to translate bear along the vector V. So remember with vectors, you are taking about that length for the vector and the direction of the vector and copying it. So it's almost like I copy and paste this error at the end of every single one. So if I keep this length and that angle, it'd be about there. So that point would give me my A prime. Okay, so then E prime, again, trying to copy that line. And again, if you have to fudge a little bit, it is okay. You are human. But we keep that length and that angle for all of the vertices. I think that might be a little long, but we'll see what we get. Oops, a little crooked. There we go. And then for B prime, we bring it up. It's about right. B prime. And we bring it out and connect. And we close the shape. So again, the shape is approximately the same. And it has shifted from the bottom of the vector. And it's almost like you just copied and pasted it. So if you have any questions on that, just let me know. Don't forget, you can always comment below to ask all of your questions. But for number 14, we are going to do a reflection, and then we are going to translate it. So starting with the reflection, Again, we're making that 90 degrees. So then it's about there. Okay, so then for C prime, I have to draw, oh, this line's longer. About there-ish. And then B prime is about there. So then you connect them. All right. So then if I am translating along vector M, I'm just going straight down about that length. Oops. It would probably help if I could actually draw a straight line. Boop. Boop. Maybe a little bit farther. Okay, by drawing this, now I have C prime, A prime, and B prime. And you connect them and then erase your lines so that it looks all pretty. Yay! Oops, and I almost messed up my labels. Y'all didn't catch me, or did you? But there is a double prime for all of that second translation or transformation. All right, so then for 15 and 16, we are going to perform dilations with the given scale factor. So for this one, we have a scale factor of 2, which means we are just doing 2x and 2y, multiplying everything by 2. So 0, 2 would become 0, 4. 0, 0 is still 0, 0. 2 times 2 gives me 4 for f prime, and 1 times 2 gives me 2. And then for g prime, that would give me 2 times 3 is 6, 6. Oops. Maybe if I could write my 6s a little bit nicer. All right. So, sorry I keep making that smacking sound. But for d prime, we are at 0, 4. There he is. And then E prime is right there, so that's 0, 0. F prime is at 4, 2. And G prime is at 6, 6. So then connecting these points as best as you can. I don't have a straight edge, and I'm trying not to move my surface too much. And there we go. All right. So then for 16, our scale factor is -1/2. So what that means is we are going to multiply by -1/2 for everything. So that would be -1/2 x, -1/2 y. So looking at 4, that 4 times -1/2 gives me -2. And then 5 times -1/2 gives me 5 halves, or -2.5, depending on how you want to look at it. So then 3 times -1/2 would give me -3/2. And -1 times -1/2 would be a +1/2. And then we would have 0 times -1/2, which is still 0. And then 5 times -1/2 would be -5 halves again. So plotting this on a graph, we would have to plot A first. So 4, 5. And then B is at 3, -1. And C is at 0, 5. So it is a y-intercept. Again, how nice. But we connect all of these points. Oh my goodness. My straight line drawing ability is failing today. There it is. All right. So that gives me those ones. So then these ones we're going to have to estimate a little bit. But 2 and then -2.5 would be about there. And that one's A prime. B prime is at -3, or sorry, -3/2. So that's -1.5. And then +1/2. So that's B prime. Notice that's the one that's farther away. And then C prime is at 0, -5 halves. So when I connect them, it should look about like this. Now, remember, some of you may be like, wait, what's happening to this shape? Why is it flipped upside down? Remember, when you have a scale factor that is negative, that is going to flip it around 180 degrees. And then, because it's a 1/2, it's going to get smaller. Okay? It's about half the size. So for 17, we are determining whether each figure has reflectional symmetry, rotational symmetry, both or neither. So looking at this pentagon, we have, drum roll, both. Because you can draw it, and I'm just going to give you one example for each of these, but you can draw it down the middle and it's cut in half. And then if I were to rotate this, every time I hit another flat point, it's going to have that rotational symmetry. Okay, so then for this little cross sign, is it reflectional, rotational, both, or neither? It is both. Yay! All right, so then for this weird oblong pie looking thingy, and I'm going to draw this on there just because I want to. Why not? We can turn it 90 degrees though. But with this little circle thing, I would say, well, we can't cut it, right? Because it doesn't look the same on both sides. And that goes both ways. If I were to do, maybe I can cut it this way, notice that this length is not the same as this length. So this one has neither, because we can't rotate it around either. Sad day. Now with this circle, as some of you might have already guessed, this is going to be both, because you have unlimited number of lines that you could draw to make it have line symmetry, but it can also be rotated at an 80 degree and still be looking exactly the same. So then for this heart, we have just line symmetry or reflectional symmetry. Wording, either, that's the same way. But we just have the line that we can draw down the middle of the heart. So if you have any questions, please comment below. I will be more than happy to answer. If this video was helpful to you, please like it, subscribe to the channel so that you can get notifications if new videos are posted. And again, let me know if you have questions, because I want to know what is still confusing to you. Thanks for watching.